Hello, everybody, and thank you all for joining us today for this educational Innovize webinar. My name is Nicole Highlander, and I'm part of the marketing team here in the Innovize Portland office. Today's webinar is the first in a series that will introduce you to modeling with XPSWM and XPSTORM. Today's session will cover the basics of hydrology in XPSWM and XPSTORM, including template settings for runoff, catchment data from GIS background data, global storms, and rain on grid. So if that's the topic you're here for, then you're in the right place. One more note here for those of you who may not be as familiar with Innovize. We have a long history of providing high-performing software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in our industry. Now, on with our presentation. I'd like to introduce our presenter. Today's presenter is Matt Anderson, our Storm and Flood Products Manager. Matt joined us in December of 2016 and comes with very valuable experience as he spent 6 years with Autodesk, most recently as a product manager. He's also spent over 16 years as a private engineering consultant. Over the past decade, he's been involved in improving the workflows and technology that engineers use to study and design civil infrastructure and water resources. Thanks again, everybody, for joining us today, and welcome, Matt.
Thank you, Nicole. I need to update that picture of me. I've got a little bit more fuzz. Before we get started, I'd like to go ahead and ask everyone a poll question. So when you select your hydrologic method, why do you select that method? Is it because you're familiar with that method? Is it because of local requirements and regulations? Is it because you're actually taking someone else's model and you're extending that or modifying that? Prior model uses that specific method. Or not sure. Maybe I should have said not sure or it depends, because in many cases I'm pretty sure that is the case. So we have a good number of 20% because of familiarity, about 42%, a little less than the prior webinar, local requirements. Prior model, 8%, it's about the same. A little higher here on the not sure, probably because I tossed that depends in there. So, okay, that's pretty good. Thank you. So the next poll question is, when you have that opportunity to select it, what hydrologic method do you select? Is it our EPA-SWM nonlinear reservoir or the runoff method that XP has? Do you rely on the rational method for most of your work, primarily? Do you utilize the SCS curve number, either TR20, TR55, something like that? Maybe I should call that the NRCS method. Do you utilize a unit hydrograph, Santa Barbara or Clark or Nash? And I highly doubt anyone here on this call now will be familiar at all with the UK methods, but there could be. We do have that, and I think we have a total of 23 different methods within XPSWM. This is not all of them here that you see. All right, so about 20% with the EPA-SWM, which is higher than this morning. Rational appears a little higher. Again, very similar to that. SCS seems to be probably the most common here in the Americas. And unit hydrograph, I think probably because we're closer to lunchtime out on the West Coast, where Santa Barbara and Nash come into play. Those are higher here. Obviously, yeah, nobody in the UK is, it's a little late, time for dinner, things like that. So cool, that is good. Those are good results. Thank you again for that. So as Nicole indicated, this is kind of the first in a series of what I call introductory webinars to kind of introduce you to the capabilities within XPSWM and XPSTORM. And I'm going to do this really that basics of hydrology, the basics of runoff within XPSWM. And doing this because, you know, as customers, you, at the end of webinars like this, you get asked for question ideas to present. And I've seen a number of requests for different introductory level webinars. We do have some on our YouTube channel that are available, but figured why not, let's go ahead and do these live, do some introductory classes. And obviously the first one that we wanted to start out with is hydrology. So in this webinar, I will kind of give you an overview of some of the template settings that are available for runoff that give you that ability to really start, you know, a model off on the right foot, if you will. Going to walk you through how to derive catchment data from GIS data and you know, ultimately compute a curve number, give you an understanding of global storms, as well as how to leverage some rain on grid to make a better catchment. Let's kind of jump into this. I told Nicole that I didn't want this to be a true theory of hydrology. It kind of dawned on me this morning after putting this together that I wanted to make sure that Hydrology 101 isn't going to be, you know, how do you solve SCS methods with, you know, showing you a bunch of equations, and I don't want to do that. But I just want to give you an idea of, you know, what we talk about, some of the supported methods, and I'll show 3 of them here. So the runoff method is really the XPSWM nonlinear reservoir. It's a, you know, a balance between precipitation, evaporation, storage, and infiltration that derives runoff. Okay, and I think the most difficult thing that you know, modelers get into, especially early modelers, and this is an introductory class or webinar, is how do you take a natural catchment and idealize it to this reservoir model, which is assuming a rectangle. Okay, and I think that's probably the most difficult thing that we have, you know, in adopting runoff. Okay, there are other elements, but you know, we have other tools, not just within XPSWM. As a company in Advise, we have a tool called Subcatchment Manager in our InfoSWM suite that gives you the ability to take some of those irregular shapes and automatically assign the width parameter to that based on number of different studies. So we have tools to help. You know, so if you've got XPSWM and you need some assistance with something like that, we can definitely submit a support ticket and we can discuss something like that. SCS, the 40% of you utilize that. A little 45% of you, it was 52 in the morning, very familiar with the SCS hydrology. Yeah, it goes back to the 50s and it's rural and things like that, but it's very common, primarily because of its simplicity. As we get probably step up to that next level, we get rain on grid. Okay, and that leverages our XP2D functionality and its ability to take a land use and its infiltration capacity to help us, make the conversion of rainfall to runoff much smaller and incorporate the hydraulics earlier, really, in the process. It gives you that ability, so you don't have to worry about a time of concentration and things like that. Rain Grid is, I think, really gaining in popularity, not only here in the US, but kind of globally. So you've got XPSWM, XPSTORM. In this case, everything that we go through today are going to be common between those two platforms. But we start out really with a template. We have that ability, when creating a model, create from template or create from the default template. We have that ability to take some selection information and embed it into that template to save you time. Set it once, use it many, to get it so that when you place a node, that it knows what method you're using and things like that. So we'll just look at a couple of settings here. So under File Properties, opens this File Properties and Options dialog. Very simple dialog, 4 elements: node defaults, job statistics, link defaults, text defaults. Gives you that ability, if you dig into node defaults, to look at some of the node data. This establishes what will be placed when you select a node, okay? And you can do this kind of live in a model, but you can also save this into the template. But you'll notice that we look at this is the standard default template, and it has information like save outflows to interface file or save results for review. It also has 5 groundwater flags that are off. So this kind of, for me, this tells me that, hey, this model is probably EPA runoff, and I don't want to turn my groundwater on, okay? Those are some easy elements to begin with to make sure that all my models start from a certain state. So let's look at, maybe you're on the West Coast and you want to use the Nash unit hydrograph. So let's think about this. Think about the steps that we would need to take to get to that unit hydrograph. And we need to add these rows using the yellow plus and folder there to select those elements from the database. So we'd select the routing method and then select unit hydrograph. And then under the unit hydrograph here, expanding that and select the unit hydrograph method, and on the drop down, select Nash, okay? Simple process. Anytime once we've done that, boom, the next node that you place in the model, or next time you've saved, put that in the template, created a new model, the unit hydrograph will be selected, and then the Nash unit hydrograph will be selected. Any and all of these values within here can be added here, so you can hopefully save time on repetitive elements. One other element that we do have is a couple of unique hydrologic methods. The Colorado unit hydrograph procedure, as well as the Los Angeles method, F0601. Okay, and those are triggered by settings within the application settings. So on the menu, Tools, Application Settings, and if you switch over to the config, you have the ability to turn that on. Okay, it does require the application be restarted because it does enable a couple of different flags, a couple of different UI elements, because Los Angeles and Colorado methods look a little bit different than what we have straight out of the box. Other things that we can set in our template, configuration keywords, okay? Catchment slope, curve number, composite, and SCS fix. These are 4 that very hydrologic keywords. So the cat slope or catchment slope, if you include cat slope equals %, it'll allow you to use a % value rather than the unitless feet over feet for the catchment slope. Pretty simple. Depends on how you visualize it. In this case, we can allow that. curve number 99. If you put curve number equals and then put a 2-digit number, integer, we allow the impervious default, if you will, from 98 to whatever number you select. Most cases it's going to be 99. I don't know any reason why not to keep it in one of those two elements, but you could set it to 80 if you wanted to. I wouldn't, but go from there. Composite. Okay, in many cases, the SCS method, we all seem to view that and do our composite calculations depending on where we're doing it. In this case, this keyword allows us to enter that direct composite number rather than having XPSWM and XPSTORM rely on our percent imperviousness. Okay, we're just going to put in the pervious curve number, we're going to put that composite number. But by doing that, we need to tell the application just to use that number with this keyword. Another element, SCS fix, is the keyword to turn off evaporation. We have in the runoff mode evaporation on. It's a small number, but sometimes we get support calls where people hand calc a certain catchment and realize that, hey, the peak isn't always the peak. Well, turn off, I should say, evaporation, and you'll get that number, because evaporation in SCS hydrology isn't in there by default. So, that's what you need to do, so you compare apples to apples, if you will. That website there, help.xpsolutions.com, display XPS configuration plus keywords, will get you, if you just put the first part, if you search for configuration keywords, there's a long list of configuration keywords. Many of them obviously are hydraulic. These are the four hydrologic that I picked out here, most pertinent to today's webinar. Another element, global data. During my years of experience in private engineering, I pretty much did 90% of my work within one geographic region, 10% going everywhere else. So I always had, all my rainfall information pretty well set up in my DOS files at that time. But in this case, we can put them in XPSWM as global data, rainfall distributions, rainfall values. But in what I'm calling a little preview here of 2017.2, we have what's called global storm ensembles. And ensembles is just a way of grouping it here in the US, because this was, our friends in Australia have done a really good job at looking at many different groupings of storms to identify really what the peak and critical flooding condition are. So here in the US, this is the situation that I see. Ensemble, I would put my Huff first quartile in there, give my storm names, my return periods, and my rainfalls. And I can actually add many more of these. Obviously, I'm just looking at 5 storms here in the global storms, but I can store the ensemble, store these rainfalls, get that in my template. So, I have this pretty well pre-built, looking at the different return periods and the different rainfall events, have all of that pre-built in my template and go from there. Infiltration methods, again, part of global data. So we can have a green amped infiltration based on, some of the soil properties that we have. That all can be baked into your template via the global database. So how do I see modeling changing? Obviously, one of the things that Atlas 14 is doing is it is discontinuing, or at least recommending discontinuing, the SCS groupings of rainfall, ST1, 1A, 2, and 3. So from a distribution point of view, that nested intensity, it dates from the 60s, and there's been a lot of changes. I'm probably showing some of my age, but there's been a lot of significant changes over my lifetime. In this case, NOAA over the last couple of years has brought in new temporal distributions and specified specifically in areas. And I think when I was looking at Florida a while ago, Florida has many counties. In fact, I think the majority of the counties here in Florida have more than one rainfall distribution associated with it. So geographically, it's probably much more precise than what was measured back in the 50s through daily. We've got now sub-hour, we've got radar and things like that give us probably a better view of some of the rainfall. And places like Texas and the Northwest, where the office is located, there are new advances coming. Atlas 14 publications will be published for those areas, hopefully soon. But in many cases, what does this mean for us as modelers? I think this means more simulations. We're going to need to look at more of these distributions, and that's really where the power of that ensemble and the global storms really come into play. So let's look at some of the details, okay? Runoff details. So when you have a node and you're in the runoff mode, not the hydraulics mode or the sanitary mode, the runoff mode, you edit the data, we have up to 5 subcatchments for that node. And in this case, I did a screenshot. I've got no area imperviousness, width, or slope, but I've got this first subcatchment checked. As I do that, we now have the characteristics of this hydrologic method. In this case, it's checked to be the runoff mode, which is the XPSWMM methods. We can select kinematic or Lorentz, SCS, or a unit hydrograph, maybe UK hydrology. Those are there, they're available. We have that ability to select the rainfall as well as the infiltration. And if we select SCS, as I'll show here in the demo shortly, SCS, kind of the infiltration is already built in, so that button will not be valid. But we have the ability to also include snowmelt, groundwater, water quality data, but we also can do what I like, and I'll show later, is some of this flow redirection. We have that ability to turn on flow redirection, so we can take maybe the 100% imperviousness and pass it to a pervious subcatchment within this node, which I think is pretty powerful way of looking at runoff that you really can't do in a lot of other applications. So let's go ahead and jump into the demo. All right, I will give that a second for everybody to catch up. So here we have a kind of a farm field in the middle of an urban city. Okay, we have an old farmstead down here. We've got a lot of urban. We've got a little bit of wetness going on here. This is probably a somewhat typical pre-development condition. Okay, whereas if this was to be developed like all of these other properties around here, we might need to do somewhat idealized pre-development condition for the property that our client owns. So in this case, I have a catchment that is pretty close to just being their property. Okay, it's not what I would say a true catchment where we follow the contours of the ground, although we do have the contours. We're looking for the pre-development release rate here for this webinar. Okay, if I turn off the catchment, we can kind of get a little bit better view of all of these, ultimately, we are discharging underneath a culvert, underneath a road that is off to the west of this project. Okay, but we also have a ditch, a channel. It's actually a concrete channel along the north edge, and we do have some flow that goes really directly there before passing through this point. So if you bear with me and just assume that, hey, this is a nice, pretty looking catchment, and imagine that we've done that irregular nature, we'll stick with this for this point. So all I did really to create this catchment is to select this layer, use the polygon tool, okay, and I'm going to go ahead and just digitize and step you through this. So I can digitize a quick catchment here. Select my arrow, select my catchment. It's a little hard to see here with the arrow photo on, but if I can get to roughly the centroid of catchment 2, I can grab that, hold my right mouse button down, and I can drag that over to node 3. In doing so, I get a drain catchment as. If I scroll over, you'll notice that subcatchment 1 is already taken. That's position 1, which is what this number represents here. I can come in here and in any of the other subcatchments positions, drain this subcatchment to node 3. Just very quickly, I will open node 3, and you'll notice that the value from this morning is still there, but we have, really the area is not there yet. If I come back to calculate this node and do catchment areas, you'll notice that, I think it was 5.11 this morning, even though I erased it. The area of the catchment that I digitized is 15 acres. So in doing that, I can now edit that. You'll notice that I now have 15.803 acres. Okay, it's not active, and it wouldn't be active until I selected that and went through the process of defining, maybe it's the SCS hydrology, a curve number, time of concentration, and it's a time of concentration that we can, if we have physical information associated with that, we can actually go ahead and select one of those, either Kirpich or the FAA or the SCS TR55 method, and that can then automatically transfer to this location. I don't want to go ahead and keep this active because I want to look at catchment 0, and we have 46 acres, and rough, based on the buildings that were demolished here originally, gone with about a 15% impervious nature. Now, width and slope come into play in the EPA SWM runoff. They don't come into play in the SCS. So we're going to go ahead and just look at what we have here under SCS. We can look at this and say maybe that's a 78. And I've calculated a time of concentration. It's about 29 minutes. And we can define hydrograph shape. I've seen different places, for example, here in Florida, where the regulations require, something closer to a Delmarva number, a 280, 284, I think, where depending on the slope of the overall watershed. But we have places, in the Carolinas where if this was a new development, we would have one curve number. The existing developments adjacent to us are required to have a second. So we have that ability and that flexibility with an XPSWM and XPSTORM to define that. We can also define or alter the initial abstraction on a catchment level. One thing before I run this, and maybe we need a little bit more or better refined elements for our curve number. And let me just go ahead and delete this. Is we can attach a GIS file that would give us that ability. And if I can come in here, select that element here, go to the quick data view, GIS, and we have a shape. It looks like a soil shape, okay, that has 541B, but it also has a curve number. And if I select a different shape, that's got a different curve number. Well, hey, I've got a catchment, I've got curve numbers, I've got overlapping polygons. Now, how do we do that? What do we do? So what we can do here under the GIS is we can import some hydrologic parameters. And in this case, I'll just select the key, and we're going to look at the curve number, and we're going to push that directly into the pervious curve number. We'll do area weighted overlapping. We can do area weighted, we can do dominant for all nodes. Okay. And let's do, might as well just do those. So we go ahead and do that. And that will give us a quick report. Okay. So, looking at node 3, we have, a number of different overlapping polygons, and it gives us the area and curve number, and ultimately the resulting curve number. I had it at 80. I think on average it's about 82.15. So when we come back to this node, we can look in here, and that value is now in there. I've never liked decimal curve numbers, I think because curve number was intended to be an integer. So I'll just drop the 0.15. And we can go ahead and run this. Okay. Now, should have did this before, but mode properties, I know I'm just running the hydrology, just running the runoff mode. So there's no hydraulics. This is really quick with the SCS. We can select our node 3, and we can come in and take a look at the values that we have. So obviously here's our flow hydrograph, peak flow of 82. But what we have on the top are some of the rates. The light blue dashed is our rainfall, and then our rainfall excess, which is our runoff, is shown. So all this stuff in here is that infiltration. We can actually turn on infiltration, we can turn on evaporation, and we can examine that. Does this make sense? Now you get this only in a single storm scenario. If we were to turn on the global storms, okay, we have the global storms here, and runoff, we can turn on, if we turn those global storms on and run with the solve manager, give it a second to solve all of those. And we look at those results. Yeah, well, there goes our infiltration and excess. So we don't get that in here, but we can kind of begin to look at this and realize, yeah, some of these numbers, I didn't run the model long enough to do all of that. Okay, but you can kind of see the different durations and peaks in the global storms and how that happens. So I can just go back up here, turn global storms off real quick. Kind of just run that here again, but I want to come down here to my second, and sorry, go back to view, restore my views. Let's go look at this small site. This is a unique site, and this is something I wanted to kind of somewhat demonstrate that we have. I've got a catchment that I drew, and I've come up here, it's a little over half an acre, about 31% impervious. And I've utilized, in this case, it's because I did that GIS elements, it's given me an 80 curve number on this, time of concentration, okay, curve number to that. So ultimately, based on my percent imperviousness and this pervious curve number, it's going to automatically calculate a composite for me and give me the single point, single discharge. Hot pink is pretty bright, so let's go and turn that off for a second. So we can kind of see, again, we've got a similar rainfall excess curve, okay, where this is infiltrated. So this is typical and standard of a composite curve number. Well, I wanted to show and contrast that with what I would call node split. And in this, I went ahead and split out the buildings from the grass, from the driveway, assuming the terrain kind of followed that. Maybe the roofs discharged to, onto the grass, and the grass then drained to the driveway. So somewhat, just stick with me on this idealized subcatchment. But I wanted to just show this so we can look at that curve again. In this case, our two buildings, SCS, we're using the flow redirection. So the runoff from node 1 goes to node split, subcatchment 2. Okay, it's obviously building, so it's 100%. And if we were to look at here, I have a 98 pervious curve number on this element. This is, we had a question this morning. This is more so that I know that this is, my buildings. It's totally impervious. Okay. And node 2 is redirected from the grass to what I'm calling the driveway, and catchment 3, its position. And again, catchment 3, this is not redirected. This is the outfall, the resulting outflow for this node. So I've taken this, really this subcatchment, even though I haven't drawn it here, I've taken all of this and idealized this into 3 different parcels of runoff, if you will, for this roughly, 2/3 of an acre, okay? And in doing that, I can get a result that has a very different rainfall excess as well as rainfall runoff response, okay? You can kind of look at this, that the excess rainfall, wow, that's much higher. So from a volume perspective, the composite doesn't seem, is that the average? Yeah. So it's something that I've always wanted a tool that gave me this ability to look at elements like that, because, different responses and how things drain to different elements and infiltrate into different elements. XPSWM, I think, does this extremely well. Okay, so that's standard. That's a watershed to a node, catchment 1D. Next, very quickly here, is rain on grid. Same model, same terrain, okay? But what I've done in this case is I've added a grid layer, okay? I've also added that same rainfall, that 1 hour Huff first quartile distribution on that. I've also added, the buildings. I've added the roads, okay? I've added this little bit of wetness, the water there. I've also then defined my farmland here. And if I were to look at the data, it has roughness for the hydraulic part, okay, but it also has rainfall abstraction as well as some infiltration based on some soil data, okay. I've got this set to silty clay loam, initial moisture, and a green amped value in here. So in doing this and running it and looking at this in the next 15 minutes, I don't think I'll have time to run it. It's quick, but it doesn't give me time to kind of demonstrate what I wanted to get to. So we can run that model and we can kind of look at the water depths. And this is pretty informative because this actually begins to tell me, versus, tells me really where the water's going versus what I would do with, a bunch of contours. I think the high was roughly in here and I was going to come along like this and arrive here. That's kind of how I determine my time and concentration manually, but looking at this, we've got this defined flow through here. There's a couple of other little elements here. There's a lot of water that's going out there. This information gives me, much more data, much more information about how the terrain and how water is going to act. If we begin to look at the velocity arrows, okay, and this will work much better probably on the adjacent elements in the urban area, than a bunch of contours. I can actually begin to look and see how, where a minor subcatchment might come into play. And I can use these velocity vectors to kind of help me divide, if I were to subdivide this 40-acre parcel into smaller subcatchments, I have that ability, okay? Now, I also have added a flow line more to measure. Yep. See if I can select that. And I want to turn my land use off so I'm not. There we are. So I can grab my graph, and it's a little short here, but it gives us a peak. Now, I didn't spend a lot of time calibrating my curve number analysis with my 2D analysis, so values may be off a bit, but we have that ability to look at not really just flow to a single point or a single discharge like we do in a standard 1D catchment to node, but we have that ability to look at rain over a terrain and capture it along a linear element. In this case, since we have water flowing really off the edge of this property into a concrete swale, it seems to hold a slightly better use than trying to get it all to come to one point, single point, if we were to look at just this parcel and ignore really everything else outside of that. So that is, rain on grid, okay, as well as the standard 1D elements, hydrology and hydraulics. So in doing that, let's kind of step through, and I think that is it. So I want to thank you for joining us today for the first of hopefully many kind of somewhat introductory webinars for, in this case, hydrology today, for XPSWM and the tools that we have here at Innovise. I am your presenter, Matthew Anderson, Storm and Flood Products Manager. That is my email address, matthew.anderson@innovise.com. If something hits you in the shower tomorrow morning about what we talked about today, feel free and give us a shout. I will gladly answer those as those come up. So thank you for joining today.